Introduction to radicals. So the first thing we're going to talk about is square roots. So to square a number means to raise it to the second power. So for example, if we have 4 squared, that means if we write it out, 4 times 4 is equal to 16. So we learned this in earlier chapters, but now a square root of a number is one of its 2 equal factors. So for example, the square root of 16 is 4. So this is what we're going to be focusing on. So when you're trying to find the square root of the number, you're going to ask yourself, what times itself gives me 16? And the answer is 4. So 4 is the square root of 16. Now, 2 very important things that we need to talk about. Every positive real number has 2 square roots. One is positive and the other is negative. So for example, the square root of 16 is going to be 4, but if you have to initiate a square root in order to solve an equation, you have to use a positive and a negative. So for example, 4 times 4 is 16, but so is negative 4 times negative 4 is also positive 16. So when solving equations, just keep that in mind. The other thing is negative real numbers have no real square roots. So in other words, you cannot take the square root of a negative number. So some terminology here. When you see this symbol, it is called a radical or a radical sign. So anytime you hear me say the radical, that's what I'm talking about, is that sign or symbol. And then the expression within or underneath a radical sign is called the radicand. So for example, here you have the radical sign, the radical symbol, and then the 16 is your radicand. And then a radical expression is an expression containing a radical sign. So these two put together, the radical sign, symbol, and the radicand, that is a radical expression. Okay, so let's talk about finding the square roots of these. When it asks you to find the square root of a number, your index we need to talk about is 2. So you're asking yourself, what can I multiply times itself 2 times in order to get 49? And the answer, of course, is going to be 7. So again, one thing that you need to understand is there is a number here, and it is a 2. When we talk about square roots or radicals, if you don't see a number, it's understood to be 2, and that is your index. So for letter B, what we have here is you have the square root of 25 over 16. Well, what I like to do on these is if you have a fraction under the radical, split them up. That's upside down. Square root of 25 over the square root of 16. So now you know the square root of 25 is going to be 5, and the square root of 16 is going to be 4. So if what's underneath the radical will not reduce, 25 and 16 will not reduce. They don't have anything in common. So if it won't reduce, split it up and then try to reduce. So the square root of 25 over the square root of 16 is just 5/4. And then letter C, notice the negative is outside. So this says take the opposite of the square root of 4. Well, we know the square root of 4 is 2, but the opposite of 2 is going to be negative 2. Alright, so here we have a decimal. So you have the square root of 0.81. Well, we know the square root of 81 is going to be 9. And the square root of 0.81 is going to be 0.9. So when you do decimals, it's the same thing. You just take the square root of 81. And we know that that's 9. And you still have your decimal where it needs to be. Okay, so the other one that we're going to talk about right now is cube root. So to cube a number means to raise it to the third power. So for example, 2 cubed means 2 times 2 times 2 is going to be 8. Well, the opposite of that is a cube root. So the opposite of a cube is a cube root of a number. It's one of its 3 equal factors. So for example, the cube root, notice 3 is your index. And it has to be written. If you're taking the cube root, it will have a 3 here. The cube root of 8, you're asking yourself, what can I multiply times itself 3 times in order to get 8? And the answer is 2, so the cube root of 3 is 8. So In a cube root, the index, like I was saying, is 3. Whatever root you are taking, that is your index, and that tells you how many times you need to multiply a number times itself to get your radicand. You can take the cube root of a negative number. So for example, negative 2 times negative 2 times negative 2 is negative 8. So you cannot take the square root of a negative number, because every time you square a negative you're going to get a positive. But you can take the cube root of a negative number, so keep that in mind. Alright, so find each cube root. So again, remember, we're asking ourselves what numbers can we multiply times themselves 3 times to get the radicand. So what number do you think you can multiply 3 times itself 3 times in order to get 27? And so the answer is going to be 3. So what number could you multiply times itself 3 times to get negative 125? And the answer is going to be negative 5. And so again, letter C, 1 over 125 will not reduce. So what we're going to do is we're going to split them up, and we're going to take the cube root of 1, which is 1, and the cube root of 125, which is 5. So your answer is going to be 1/5. Alright, so let's talk about finding nth roots. So we talked about square roots, we talked about cube roots. Now let's talk about anything higher, which would be an nth root. Other roots can be found as well. The nth root of A is defined as the nth root. Again, this is your index. A is your radicand. So the nth root of A is equal to B if and only if B raised to that index, in other words, what times itself that many times, will give us A. And that's what we've been talking about. So if the index n is even, the root is not a real number when A is negative. So basically it goes back to the square roots. 2 is your index for a square root, and 2 is even. You cannot take the square root of a negative number. Well, let's take it even farther. You cannot take the even root, the square root, the fourth root, the sixth root, the eighth root of a negative number. However, if the index is odd, 3, 5, 7, 9, the root will be a real number. So you can take the odd index root of a negative number, and your answer would be negative. So let's look at this. If we have the sixth root of 64, you're asking yourself what number times itself 6 times will give you 64? And the answer is going to be 2. So here, what number times itself 5 times? Now look, we have an odd index and we have a negative number, so this is doable. What number times itself 5 times will give us negative 32? And the answer there is going to be negative 2. Now, when you see a problem like this, you're just going to put not defined, no solution, whatever, because we've taken the even root of a negative number. So you cannot do that. So this is not a real number since the index is 4, and that's even, and the radicand is negative 16, which is negative. You cannot take an even root of a negative number. So your answer is no solution here. Alright, simplifying radicals containing variables. Radicals can also contain variables for any real number A. So again, you have the same concept here. The square root of anything squared is the absolute value of itself. So here, simplify each expression. So notice that I have the square root. Remember, there's an understood 2 here. The square root of 64x to the 10th power. Well, we know that the square root of 64 is 8, and then watch, we have 10 x's here. So if I take my exponent and basically divide it by 2, then I'm going to get 8x to the 5th power. So with your numbers, with your coefficients, 64, you're going to take the square root of 64. But with your variables and your exponents, the easiest thing to do is to divide your index into your power. And we'll talk about that later on why you can do that. But for your coefficients, your whole numbers, you're going to take the square root of those. What times itself 2 times will give me 64, and the answer is 8. But then when you have your variables with your exponents, you are dividing your exponent by your index. And so we get x to the 5th. So let's look here. We're taking the cube root of negative 8x to the 6th. The cube root of negative 8 is negative 2. Negative 2 times negative 2 times negative 2 gives you negative 8. But then we're going to divide this exponent by this index. So 6 divided by 3 is going to be 2. So you have negative 2x to the 2nd power. Okay, so here we're doing the square root. I don't see a number here, so it's understood to be a 2. And so the square root of my coefficient 25 is going to be 5. And then I'm going to divide these exponents by my index. So 2 divided by 2 is 1, and 20 divided by 2 is 10. So we should get 5ab to the 10th. Okay, with a quotient, we have a negative out here, so that just means we're going to take the opposite of whatever we get under here. This under here will not reduce. What's under your radicand basically will not reduce. So what we're going to do is we're going to take this cube root of each individual factor. So the cube root of 64 is going to be 4. The cube root of a to the 3rd is going to be a. And the cube root of b to the 9th is b to the 3rd. And then of course we have to take the opposite of it. So we should get negative 4ab to the 3rd.